In this video, we're going to cover connections within Inspire. Up till now, we've been utilizing models that are just a single part, but many of the types of parts that we're going to want to be doing analysis and optimization on are going to consist of multiple parts, potentially large assemblies, and we want to make sure that we're accurately modeling the interaction between all of the different parts in our model. So this particular model, I'm sure you can identify it as a drone body. We're going to take a look, and we can see here that there are many, many different parts that make this up. And we, of course, want to make sure that they are properly connected together. So we can come over here to the model browser and see all of the different parts that we have, and we can see all the information about each one of the parts down in the property editor. And if I right-click here and select mass, we can also see the mass. So that's all the information about the part, but now let's take a look at how things are connected. And before I go on, if you've been following along in this series, you might notice now that I am using version 2020 of Altair Inspire. Previously, I was in one of the 2019 point releases. So in between my videos here, the latest version of Inspire did release 2020. If you don't have it, I would highly recommend you get your hands on it. But that being said, if you're working in a previous version of Inspire, don't worry about it. I'm not going to cover any of the features that are specific to 2020. We'll do those in later videos. So the change in release is not going to affect these videos here. Okay, so anytime we have geometry, we have solids that are in contact within Inspire, those parts are going to be bonded together. And we can review that by coming into the structure ribbon and taking a look at contacts. The first time we take a look at it, it might take a little bit longer depending upon the complexity and the number of parts you have in your model, because it will be calculating all of the different contacts. And they are going to show up in blue. Blue indicates that we have a bonded contact. Those two solid parts that are coming together are firmly bonded together. Think of it as putting in crazy strong, infinitely strong, crazy glue on the surfaces, squishing them together, and they will not part. They will act together. So this part, as it is, will act as a whole. We don't need to worry about it. I could start running an analysis on it, and it would run perfectly fine. And this would all of these different parts in this assembly would be properly connected together. The problem that we have in this particular instance, though, is that is not necessarily always the exact way that we want to model things. If we take a look at this quadcopter, for example, so let me right-click to get out of the context. So you see we have this arm that comes in, and this is connected to this, which is perfectly fine, and this is connected to this, which is perfectly fine. But if we look back at our contacts, we can see a blue surface up here and a blue surface down here, and actually these blue tubes going down here. And if we take a closer look at the model here, what we're seeing is this arm is now bonding to the upper plate and bonding to the lower plate. And then even these geometric representations of the bolts, they're bonding along the entire surface of those as well. So that means that everything is properly connected together, but in actuality, that is not a perfectly accurate representation of this part. There is nothing bonding this to this or this to this. What actually should be happening is they should be contacting each other so they can't pass through, but they should be able to move relative to each other if necessary, or even part from each other if necessary. And so what we want to do is we're going to get rid of the geometric representations of all these bolts. They're fine, but they're actually affecting the model negatively. Because these are solids that are contacting the other solids, we're getting that bonding here. What I want to do is I'm going to use Inspire's fastening capability to create Inspire versions of these fasteners. And you're going to see that's going to have a real nice effect on our model. So I'm just going to come over here. I'm going to click that top hexagon socket screw. And I'll click on, do a shift select to grab them all and click delete. And then I'll come down here to these and do a shift select and delete those. So those are all gone now. And Coming to look at the contacts again, this model still would run perfectly fine. This is bonded at the top and the bottom. But again, we want to get a more realistic, real world scenario. So I'm going to come over here to my fasteners. I'm going to select that. And you'll see what it will do is it will identify holes that run through multiple parts. So a through hole, so a hole that runs through this part and through this part and through this part. So if we look down there, we can see through those holes. It's going to model a bolt in those cases. And a hole that runs through multiple parts but not completely through. So for instance, this hole up here runs through that top plate, but then it stops in somewhere about here in this bottom plate. So it would be a blind hole. What it's going to do is it's going to model that as a screw. So coming back here to the fasteners, all of these tubes represent holes that it has identified as running through multiple parts. And if I click fasten all, you can see automatically it goes through and puts those fasteners in there. And that's pretty neat. And now what that's going to do is it's going to hold this together. But where some of the true power in this is now if I come back here to contacts, you'll see that any solids that were connected together via the bolts and the screws, Inspire has automatically changed that contacting surface from bonded to now a contacting definition. And what contacting definition means is they will no longer be permanently stuck together. They cannot pass through each other, but they can slide along each other. And by default, they can't separate from each other. But we'll hold that, and we'll get back to that. We'll get back to that in a few minutes. So think of these as imagine take two incredibly strong neodymium magnets, put some oil between them, squish them together. You can slide them across each other, but you can't separate them, and they will not pass through each other. That's kind of the effect that we have going here. So now this is a much more realistic effect, because what it's going to do is it's going to no longer force this bond down here and this bond up here to carry the connection between the two, but it's going to utilize this fastener to carry that connection. The fastener, if we take a look at it, it actually has some properties as well. It will be assigned a material, and we can even assign a pretension force to those fasteners. So if you want to model some pretensioning, we can put those in there, put that information in there. So we just enable that and indicate a force in whatever, we're in millimeter Newton second. So it's going to be in newtons. So you put a force in whatever force unit you're using. And then we can actually also enable these to be utilized in optimization. And what that will do is, as you can see here, it's calculated the allowable, let me expand this out a little bit more so we can read what that says, the allowable axial force and shear force. And that's going to be calculated based upon the size of the bolt or the screw, and then the material that it's made out of. So that's just going to be an auto calculation. If we have more specific information about that, we can put in an axial or shear force. So we turn off auto calculate and just put in the values for us. And what will happen then is that will be included in the optimization criteria. And we'll be having a video on optimization coming up. But when it goes through and it does its optimization, one of the things that it will continually be checking is to make sure that we don't end up with forces in this area that could potentially result in an axial or a shear failure of that. So we can think of that as a constraint on the optimization, limiting on the amount of force in axial or shear that we're seeing in this region here. So now this is a much more accurate representation of this model. We're getting the proper behavior here, and we'll talk again about separation in a second. But one of the things that it missed, you can see down here where we've got these spacer tubes, it put them through there because it had the hole going through. But one of the things that it missed are the two bolts that were in this region up here. And the reason it didn't catch them was because with the spacer not being there, these two holes were way too far apart. But we can compensate for that by coming here and select that top hole and select the bottom hole. And now if we come and select the top again, it'll put that bolt in there. So we've identified that these are through holes that we want to bolt through, even though they're much farther away than it was able to automatically select. When we're doing bolts, and I won't do it on this model, but just to show you some other fastening tools here, or ways that we can use fasteners. So it didn't select this hole right here because it's not a through hole. But if I do indicate it and have absolutely nothing else, it will create what we call a grounded bolt then. So this would be utilized if I had a plate, and since there's a screw not going through multiple plates or multiple parts, it assumes that it's grounded. So it's a useful way of using a fastener to ground your part as well, not just using the constraints that we talked about in the analysis section. Now, finally here, if I come here to Analyze, and you'll get the same option in the Optimize as well. So if you come here to Contacts, you'll see the default here is sliding only. So this is now referring to those green contacting patches that we talked about earlier. The default is sliding only, and what that means is, as I'd mentioned, they will slide along each other. They can't pass through each other, but they also can't separate from each other, and that is the default. But we have the option to select sliding with separation. And what that will do is it will be constantly taking a look at those contacting surfaces. And if it determines that the force would result in those separating from each other, it will allow that to happen. So we could get separation. So if you imagine if I had a force going up on this arm here, if it was sufficient, I potentially could see some separation in this area. With sliding only, that would not be allowed to happen. Sliding with separation, it would allow this to part from there. The reason why it's not on by default, and the one slight downside to it is constantly then calculating or taking a look at the forces in the areas of contacting surfaces. I've only got, 8 of them on this model, so it would not affect the analysis time too much in this case, or barely at all. But if you had many, many contacting surfaces in your model, it could potentially increase the analysis time. So it doesn't hurt it to leave sliding only on. And in fact, if you do not enter, if everything's purely in compression and you would never see separation, leave that on. It's gonna go a little bit quicker, but the more contacting surfaces you have, the longer it potentially could take if you enable sliding with separation. Now, another form of connection that we have within Inspire are the connectors. Connectors are just going to create one-dimensional or 1D element connections, and we just can select a part to another part, and it will create a connection, and we can establish them as either flexible or rigid. Think RBE3 or RBE2, RBE3 for flexible, RBE2 for rigid. And it's just a simple way of connecting things. They're going to be non-analytical. So they're used when we just need to connect things together and we don't need to worry about the analysis of the connection. Let me delete that right there. Now, we don't really have it on this model here, but another way of connecting things are with joints, and they work very similar to the fasteners. So we can create multiple types of joints. You can see it's detected these for planar joints, but primarily these are used in the case of holes, and it allows us to create pins, and we can create them as either just a sliding pin, which won't have these clips on the end of it, or just a regular pin which has the clips on the end of it. So if I had multiple, in fact, let me do this. Let me get rid of, say, this one right here. And we'll come back to the pins here. Oops. So you see it's found that tube, and if I select it, so now let's put a pin through there. The default is clipped so that it will not be allowed to separate, but they can rotate freely. Or a sliding pin, now these could slide up and down the pin as well. So we can pin things in that manner. And then the final way of connecting is for spot welds. Now, spot welds won't work on this part. Spot welds will only work on surface geometry. So let me bring up this other model here. So what I've done is I've created these two surfaces here. These are not solids, these are surface parts. And what I can do is I come to spot welds, and you see if I now pick either one of these, wherever the location that I select that, it's going to put a spot weld. And we can specify the diameter that we want. So maybe I want a 5mm spot weld. And then I can continue going through and putting spot welds through my part here. And you'll notice with the legend here, these are 2T spot welds. If I had another another surface here, I could do 3T or 4T spot welds as well. But that is a way of representing spot welding in the case of surface geometry, and that spot weld will appear wherever I click. So if you need the spot welds very specifically located, you're probably going to want to include some points on the part. So that's pretty much how we connect things together within Inspire. We can allow Inspire to handle contacts by developing bonded contact surfaces, or we can use fasteners and joints to connect holes, connectors for simplistic connection representations, and then spot welds for 2D surface geometry. Uh, Thanks for watching.